All right, here's two questions to deal with rational expressions. First one we're dividing, and the second one we're adding or subtracting. Okay, when you're dividing fractions, typically what you do is you invert and multiply. So you leave the first one alone, change the divide to a multiply, and you flip this one over, or find the inverse. So 2p squared over 8p minus 8. And then you're looking to see if you can cancel, like taking out a factor of 1. So if there's something on the top which cancels with something on the bottom, you're taking out a factor of 1. So you need to factor first. So I'm going to factor that first one. I'll take a 2 out, and then a 2 I can't do anything with. 2p squared I could write as 2 times p divided by this. I'm going to factor an 8 out, leaving me with a p minus 1. Now I look for anything on the bottom to cancel with anything on the top. So there's a p minus 1 and a p minus 1. Here's a 2 and there's a 2. Is that all? I thought I could cancel a p out. Oh, hold on. Where'd I get this 2 from there? Should have been a p. This should have been a p, so that 2 should still be there. So this p I can cancel with this p. And then, so what am I left with? On the top I have 2p, and on the bottom I have 8. Now the 8 I could write as 2 times 2 times 2. So I can cancel these 2's. So my final answer would be p over 4. Hold on, I forgot about this 2 over here. So I can cancel, that was a 2 from over there, so I should have had an extra 2 there. So this 2 and this 2 will cancel. So really the answer is p over 2. Sorry that was a little convoluted because I'd missed that 2, but I think that's right now. Let me rewrite it. 2 times p minus 1 over p times 2 times p over 8 was 2 times 2 times 2, and then a p minus 1. So p minus 1's go, this p goes with that p, this 2 with that 2, this 2 with that 2. Yeah, so I'm left with a p over 2. Okay, so next question. Instead of multiplying or dividing rational expressions, this time I'm subtracting. Rule for adding or subtracting fractions is they have to have a common denominator. And so what I'm going to do is factor both of these. So it'll be x over x minus 4, x plus 4, minus 5, and then this factored is x plus 4 and x plus 1. So my lowest common denominator, I need to have an x minus 4, an x plus 4. From here, here's an x plus 4, but I already have one. X plus 1 I don't have, so that needs to be part of my denominator. So I need to change this denominator and this denominator to be that. So the first, I'll change x minus 4, x plus 4. That's what it is originally. And originally this one is 5 over x plus 4, x plus 1. So this first one, it needs that x plus 1. So if I put an x plus 1 on the bottom, I also have to put an x plus 1 on the top. Similarly here, I don't have an x minus 4, and that's part of my lowest common denominator. So I need to multiply the top and the bottom by that same thing. Now some people try and cancel at this point, but you don't cancel because you want to keep that denominator there. But now this is the same as this, so I can have one big denominator. X minus 4, x plus 4, x plus 1. And now I just combine this top stuff. So I'll just rewrite it. X times x plus 1 minus 5 times x minus 4. And now let's multiply this through. X squared plus x minus 5x plus 20 all over x minus 4, x plus 4, x plus 1. And then finally, I'll collect like terms here. X squared minus 4x plus 20 over that lowest common denominator. Now, I would also try and factor that if I could and see if I can cancel any more, but I don't think you can factor that. Like 10 and 2, that doesn't give you 4. 5 and 4, that doesn't give you 4. Yeah, you're not factoring that. So that would be my answer. Hopefully that helps you with those two questions.